65 million years ago, something was buried in rock that should not exist. Microscopic metallic spheres, forged at temperatures only industrial processes can reach, resting in stone that predates every human civilization by an almost incomprehensible margin. Not one location, multiple sites in patterns that mirror the fallout signatures of modern nuclear testing, and yet there were no humans, no factories, no reactors. So the question that should keep you up at night is this: what if we were not the first? In 1980, geologist Walter Alvarez found a thin band of iridium in Italian limestone, a chemical scar left by the asteroid that wiped out the dinosaurs 65 million years ago. That single discovery rewired how we understand planetary history. It proved something important. A civilization-ending event can leave a readable fingerprint for millions of years, which means if an asteroid from space can do that, a civilization burning fossil fuels and splitting atoms absolutely can. Scientists Adam Frank and Gavin Schmidt took that logic and built the Silurian Hypothesis, named after a fictional species of intelligent reptiles from Doctor Who predated humanity. And the question is no longer as absurd as it sounds. Here is the scale problem that most people never truly grasp. Human civilization, all of recorded history, agriculture, cities, writing, spans roughly 10,000 years. Earth is 4.5 billion years old. That means our entire existence occupies less than 0.0002% of this planet's timeline. A prior industrial civilization that lasted 1 million years and vanished would leave a layer in the rock roughly 1 millimeter thick. We might have walked right over it without a second thought. The fossil record is where the first cracks in the conventional story appear. Paleontologists describe it as a book with most pages torn out. There are sections where life simply vanishes and then returns, different, more complex, seemingly transformed. The Cambrian explosion, 540 million years ago, is the most dramatic of these. In geological terms, almost overnight, complex multicellular life with eyes and skeletons and nervous systems appears out of nowhere. No clear evolutionary ancestors, no gradual transition, just sudden, staggering complexity. Standard evolutionary theory struggles to fully account for it. And then there are the gaps that coincide, suspiciously, with massive atmospheric upheavals. Some of these gaps are too systematic, too well-timed to be simple preservation failures. The Great Oxygenation Event 2 billion years ago is a case study in planetary-scale disruption. Oxygen, which was toxic to most life at the time, surged through the atmosphere and poisoned the dominant organisms of that era into near-total extinction. What survived rebuilt the biological world from scratch. The cyanobacteria explanation is the mainstream answer, and it may well be correct, but the precision and the timing nag at researchers who examine the record closely. Stability in the fossil record, then sudden mass death, then rapid diversification into new forms. That pattern repeats over and over throughout geological history. Could some of those punctuation marks represent something other than purely natural events? Could some represent the signature of a civilization that altered its own atmosphere and paid the ultimate price? This is where the hypothesis moves from speculation to testable science. Every major industrial civilization leaves isotope signatures. When you burn ancient fossil fuels, you release carbon depleted of carbon-14, creating a distinctive ratio detectable anywhere: tree rings, marine sediments, Antarctic ice. Modern industry's fingerprint is already embedded in the geological record of the last 2 centuries. Geologists have now found anomalous isotope signatures that predate us by millions of years. The Permian-Triassic boundary, 252 million years ago, contains carbon isotope shifts equivalent to burning every known coal and oil reserve on Earth, and it happened in what the geological record describes as a geological instant. Colorado, deep ocean sediment cores, formation after formation. Microscopic metallic spheres, the kind produced exclusively by high-temperature industrial combustion, embedded in rock strata formed long before humans developed the ability to smelt iron. The distribution is not local contamination. These particles appear across multiple continents in patterns consistent with global atmospheric dispersal from numerous simultaneous sources. That is not a volcano. Volcanoes have their own isotope signature, and scientists have checked. These do not match. Plastic is our civilization's most honest legacy. Microplastics are now everywhere on Earth, in Arctic ice, in deep ocean trenches, in the lungs of animals. They will persist in the sediment record for millions of years. Future geologists will have no difficulty identifying the thin layer of synthetic polymer that marks our era. What is extraordinary is that ocean sediment cores from remote basins now show what appear to be synthetic polymer particles in layers formed millions of years before humans invented petrochemicals. Not one anomaly, discrete layers separated by millions of years, distributed globally. If those particles are what they appear to be, the implication is profound and deeply uncomfortable. Technological civilizations have risen and collapsed on this planet, not once, but potentially multiple times, and we are walking on their ruins right now. Their cities gone, their culture gone, their biology perhaps gone, but their waste, the irreducible chemical legacy of industry, preserved in stone, waiting to be read by a species smart enough to ask the right question. In 1972, French scientists made a discovery in Gabon, Africa, that stunned the physics world. Deep underground, they found a uranium deposit that had undergone sustained nuclear fission reactions naturally 2 billion years ago. The Oklo Natural Nuclear Reactor. No human engineering involved, just the right concentration of fissile material, the right geometry, and the right geological conditions. It ran for hundreds of thousands of years, and it left a signature that survives to this day. Specific isotope ratios found nowhere else in nature, unmistakably the product of nuclear reactions. Oklo established something crucial. Nuclear reactions leave a fingerprint that survives for billions of years. Researchers then systematically searched Earth's geological record for other such signatures. What they found is either remarkable contamination or something that demands a new explanation. Uranium deposits in Kazakhstan contain isotope ratios that match the byproducts of nuclear weapons testing in rock layers formed 50 million years ago. Similar signatures appear in geological formations across 6 continents. Greenland ice cores contain radioactive isotopes producible only through precisely controlled nuclear reactions, appearing in distinct layers separated by thousands of years. Not one event, multiple events, followed each time by complete cessation. Here is what makes the nuclear evidence especially compelling. It doesn't stand alone. The artificial isotopes appear alongside anomalous carbon signatures, microscopic industrial spheres, and synthetic polymer particles, and they correlate with mass extinction events. The pattern is not random noise in the geological record. It clusters, multiple lines of independent evidence converging at the same moments in time, pointing towards the same disturbing interpretation. Episodic advanced industrial activity, followed by collapse, followed by recovery, repeated across deep time. Look at the Permian-Triassic extinction with fresh eyes. 96% of marine species, 70% of land vertebrates gone in what the geological record suggests was a geologically rapid event. What troubles researchers is the selectivity. Species with similar ecological niches and similar environmental tolerances showed wildly different survival rates. Some groups were decimated while their apparent ecological equivalents survived. That pattern is difficult to reconcile with a purely natural, indiscriminate kill mechanism like volcanic winter or methane release. It looks in some ways like something targeted, something selective, even if unintentionally so. SETI, the search for extraterrestrial intelligence, has developed increasingly sophisticated tools for detecting the chemical and physical signatures that technological civilizations leave in their environments. Spectroscopic analysis of atmospheric chemistry, detection of industrial pollution isotopes, identification of artificial compounds. When researchers applied these same technosignature detection techniques to Earth's own ancient geological record, the results were described in the papers as, quote, unexpectedly positive. The tools designed to find alien civilizations across the galaxy are finding something when pointed at our own past. The Silurian Hypothesis is not a claim that ancient reptile people built pyramids. It's a serious scientific framework asking a rigorous question. Given what we know about how industrial civilizations alter their environment, would we recognize the evidence of a prior civilization if it existed? The answer the evidence increasingly suggests is that we might be looking right at it and calling it something else. Natural phenomenon, geological anomaly, preservation artifact. The philosophical weight of all this is something I find genuinely staggering. We think of ourselves as the beginning of something, the first chapter of intelligence on this planet. But what if we are closer to the middle of the story, or even near the end of a very long cycle? What if consciousness is not a lucky accident that happened once on this pale blue dot, but something this planet has been cultivating and losing, and cultivating again across geological ages? The universe is patient in ways human minds cannot truly process. Deep time is not a backdrop, it is the story itself, and the message written in rock, in isotope ratios, in microscopic spheres of industrial metal scattered across every continent, is a message we are only now learning to read. Whether we are the first civilization to read it, or simply the latest one to try, that question may be the most important one our species has ever asked. The choice of what we do with this knowledge and with this planet is ours, for now.